Welcome to converting between rectangular and parametric equations. So the idea here is that since a curve defined by parametric equations is is simply a curve in the xy plane. It would seem reasonable that we can go back and forth between an equation for the curve just in xy and parametric equations. Between rectangular and parametric equations. It is extremely easy if there is no constraint on time to just simply set x equal to t, and we can go from rectangular to parametric. But we can also do this even with constraints on the time. So for example, let's consider the equation y equals 2x to the 4th and find parametric equations x equals f of t and y equals g of t for the curve where t is equal to dy dx. So the first thing we find dy dx. So dy dx in this case is simply 8x cubed. Once we have our dy dx, then we can solve for x in terms of t. So we have t is equal to dy dx, so t equals 8x cubed. That means that 1/8 t is equal to x cubed, or x is equal to 1/2, that's the cubed root of 1/8, times t to the 1/3. Then we can find y in terms of t. So y was 2x to the 4th. So that is 2 times 1/2 t to the 1/3, entire thing raised to the 4th, otherwise known as 1/8 t to the 4/3. So our parametric equations we have x equals 1/2 t to the 1/3 and y equals 1/8 t to the 4/3. So this is one approach we can take. This is a fairly constant constraint on time to have time set equal to the slope of the tangent line. For another example, let's now eliminate the parameter from the parametric equations. In other words, set it so it's just an equation in x and y. So all we need to do is we can solve one equation for t. It does not matter which equation you solve for t. I usually go for the simplest one. So we have y is equal to 1 over t plus 3. That means that t plus 3 is equal to 1 over y. And therefore t is equal to 1 over y minus 3. Then we can go ahead and substitute in to the other equation. So we had x was equal to 1 over t squared minus 9. So this would be 1 over y minus 3 squared and then minus 9. This becomes x equals 1 over y squared minus 6 over y plus 9 minus 9. Or x is equal to 1 over 1 minus 6y over y squared, which we will then write as x equals y squared over 1 minus 6y. So again, it's just a matter of algebraic manipulation. Some problems are going to be more challenging than others to solve for t and go from there. But for converting from parametric to rectangular, it's just a matter of solving one equation for t and then plugging in. So this is our rectangular equation. And next up, we will go ahead and look at what equations, what parametric equations define the various conic sections we looked at in the previous section.